Welcome to today's tutorial on using GRes, created by TerraCode Analytics for two-dimensional electrical resistivity methods. We begin by confirming the project and its location, because every later map, survey line, and interpretation must be tied to the correct site. Site intelligence records the geological setting. Here, the terrain is classified as sedimentary, giving the inversion and interpretation a useful geological context. The survey data is now imported and checked. GRes recognizes the field files, instrument, array, and survey configuration before processing. This validation step is important because reliable interpretation depends on correctly identified and complete measurements. The processing stage converts the field measurements into subsurface resistivity information. The default inversion settings are accepted, and the 4 survey lines are submitted for calculation. The calculated sections are reviewed line by line. The measured and calculated pseudosections are compared to assess how well the model reproduces the field data. This quality check helps distinguish meaningful subsurface patterns from poorly fitted results. After processing is complete, the results are sent to interpretation. Reviewing the 4 lines together helps identify consistent lateral and depth-related resistivity changes across the survey area. The final technical report brings the workflow together. It documents the processed lines, interpretations, limitations, and professional conclusions so the results can be reviewed and used for further geological or engineering decisions.